Hey guys, Ben with Big Stuff here. Welcome to another Big Stuff training video on our Gen 4 ECU application. So in today's video, we're going to be going over how to configure the electric fan outputs as well as configuring them for pulse width modulation use. So if you go into the software, there's a couple things we're going to go over on how to actually configure these and set these up. The first way we're going to talk about here is go to the system section. You're going to go to the operating configuration. Now, if you have an older version of our software, you may have the older look. That's totally fine. This is at version 3.6, which is our newer updated interface look now for the software. So if you do have the older look, you'll still have a system menu and you're going to go into the operating configuration and you're going to still see all the same data. It's just going to be shown differently here, okay? So in the operating configuration, you're going to see down here that we have our fan temperature control. Fan 1 is on at 205 degrees. Fan 1's off 197. Fan 2 is on at 210. Fan 2 is off at 200. Okay. So very basic stage fan control. It's been around forever. If you just have the key on with our system, it will not turn the electric fans on. Okay. Electric fans have to see over a couple hundred RPM. So this way, with the key on, the fans are just not blasting, just running based on the temperature. If you have the engine, or if the engine's been running and you just turn it off, and now you're sitting there with a warm engine. Okay. So this is where you configure the fan on and off temperatures. If I go to the pin configuration section here, you're going to see up here that our defaults, our fan 2 enable is header 1 pin Nancy 3. And fan 1 enables header 1 pin R3, okay? That's your staged digital outputs for just turning electric fans off on, been around forever, works great. Now, if you want to start diving into the pulse width modulation, you're going to come all the way down here to the very bottom, and you're going to see here that we have our PWM output section, okay? There are 6 PWM outputs on the ECU total. Now, the first 3, depending on how your application is currently, could be reserved. The first one that we have is reserved for the nitrous PWM output. So if you're using the progressive control, this is utilized by the internal logic to run the progressive nitrous system. Okay, so you can't use that one. If you have transmission control, you're going to have the TCC pulse modulation and the force motor control through these 2 PWMs, so they'll be unavailable. But we have 3 free spares that are always available, and that's PWM 7, PWM 8, 9, 8, and 9. Okay. So in this case, you can see here in this application, we have it set up for electric water pump. I've typed this name in. The factory name there will just say stage 4. And again, if you're on the older software, you won't be able to type in that new name. It'll still work exactly the same, or else you could upgrade the firmware with it. Okay. So then on the second output is the electric fan output, which is PWM 08. You'll see there that it says LS. That indicates that this is a ground output, okay? This is going to be a ground output to a solid state relay, which is going to be pulse width modulated to run these 2 outputs. All of them are ground outputs except for PWM 05. This is a 12 volt out that we give you if you want to use a high side output. Now, this will be reserved for the bump as well. So if you're using bump control, okay, for a turbo car you want to bump in, this will not be available for just a general purpose output because of the fact that it's being used for the bump control, okay? So the first thing you're going to do is you can change name to whatever you want. You can leave them factory names. In this case here, in this application, we have an engine that has electric water pump that we're solid state controlling, and we have electric fan that we're solid state controlling as well, okay? So you'll see here too that the header 1 pin Nancy 1 is the water pump output. Header 2 pin L3 is the electric fan. Now remember, header 2 is on the side of the SD card. Okay, header 1 is on the side of the engine side. That's where your RJ45 connection is to actually plug in and communicate with the ECU. Okay, so now that we actually have these renamed or just looked at here, we've selected them as this general purpose output, you may actually have them set up over here as stage 4 and stage 5. Make them PWM 07, PWM 08 because we're going to use them for its general purpose application. All right. So now that they're set up there, a couple of things that we have to do now is we need to go over to our custom port editor, okay? Now inside the custom port editor is where we're actually going to turn these tables on. Remember, we're just turning the table on. The table itself is what's actually going to be controlling solid state relay based on however we want this to work, okay? So over here, I've configured a couple things already. I've done one already. The electric water pump, I've renamed it. If you want to rename it, you can come over here to this little icon here and enter the alias name. I always like putting what it is. That way, instead of just putting a name, I know, okay, I'm on PWM07. That way you'll know exactly what output you're working with, okay? For example, this is the factory name, and you'll see here it says low side PWM09 only. So I like to put the PWM number that's in there so I don't lose track of what's what, okay? So if I come in here to this output right here for the electric water pump for this example, I've checked the enable box. The power on value is off and the active is on. I don't have any type of active and active delays or pulse set up here. But in the active conditions here, you can see that whenever all this logic goes true, we turn on. That's what the active value means. When all of this logic is false or is not satisfied, we come back over to here and the power on value is off. So in this application here, I have it when the engine RPM is greater than 300. That's what filter RPM is. If you hit the pull down, you have a ton of different stuff you can choose from here, but I'm choosing filter RPM. And the throttle position is less than 90%, and the vehicle speed is less than 50 miles an hour, okay? So in this application, we do not want that because this is for an electric water pump, all right? So now we're gonna come in here and we're gonna turn off this logic. We're gonna say no additional conditions, and now because this is the water pump, anytime I go over 300 RPM, we're going to turn on. But let's just say because this is the water pump, I want to turn it on and have that table turn on based on coolant temperature. I can come over here, I can do an and condition. I'm going to click no down here, and I'm going to go in the T section, which is what I'm already in. If I press T, I'm already in here, and I'm going to look for the temperature, coolant, Fahrenheit filter. That's what this means right here, okay? And I'm going to say if the coolant temperature is greater than 50 degrees. Now, again, I don't have to do this. I could just have this table always on, and the table will actually control based on how I'm going to set it up. But I can just put any actual conditions in here to turn on that table. Remember, this is just the table we're turning on. This is not actually configuring what the table is doing. This is my table on or is my table off for pulse modulation control, okay? So let's just say, you know what? We're not going to do any condition. We're just going to say if we're over 300 RPM, then this table is going to turn on, okay? Let's go over here to the electric fan. We're going to set this one up. This one's never been set up before. I'm going to come over here. I'm going to click enabled. Now my logic is saying, okay, power on is off, active is on. So now for the electric fan, I'm going to come over here. I'm going to press the letter F. I'm going to come down here to filtered RPM. I'm going to say my filtered RPM is greater than 300. Put a little bit of hysteresis in there for a little bit of differential. Okay, now this is for my electric fans. Now I'm going to say and the throttle position, okay, TPS underscore filt is my throttle position right here, okay, is less than 90% with a 5% hysteresis, okay, and the vehicle speed, okay, this is how fast the vehicle is running, okay, vehicle speed is less than 50 with a little bit of hysteresis as well. So now if I'm traveling down the road, obviously I don't need any airspeed or electric fan. This will save some draw on the alternator. If I go wide open throttle for a brief bit, okay, then more than likely I don't need the actual electric fans on as well. Okay, if I'm going over 50 miles an hour, I should have a way more than enough airflow to get airflow across that radiator without needing electric fans. But again, this is just enabling or disabling the table. All right, but you can choose to do this any which way you want. If you have any conditions that you actually want custom, send us a message. We'll be happy to get you set up with however you want these outputs to turn on. And you also have to remember too, this is just an example of electric water pump, electric fan. This can be utilized for anything. Any type of solid state relay control, you can do anything you want with it. In this application, we're just doing a water pump and a fan, okay? So now that these are all configured, I'm gonna go apply. Okay, so that now sets it up, and we're now good to go in the custom port editor. These tables are going to be enabled. Now I'm going to come down here to the custom section. Now again, it may say generic for what you're doing, okay? So now I'm going to come over here, PWM07. And now what you're going to notice is here, we're going to have coolant down here on the bottom, and we're going to have duty cycle output on top, okay? So this is the water pump. So right now I have it set up so that when my table is active, okay, when I get to these temperatures, I'm going to send the duty cycle output of the water pump to this duty cycle, okay? So down here at 50 degrees, I have nothing. Okay, 50 degrees is pretty cold. Then as we start to get in this 54.7 degrees, 30% duty cycle, then 35% duty cycle, 60. So you start ramping it up. By the time we get to 120 degrees, that water pump is full speed, okay? Again, you can do this any which way you want, but now this has got PWM07 configured correctly, okay? So now if I come over to PWM08, you're going to see this one's set up a little bit differently. We just extend out that range a little bit more. Okay, so you can see here that going down to 50 degrees again, we have nothing going on. But as we creep up and we start moving up in temperature, we start increasing that output. So right now it's 83 degrees. So we're going to go to about 50% duty cycle. You have to remember, if you get really low in the duty cycle, you're probably not going to get the fan even run. You've got to give it a little bit of duty cycle for it to actually start turning, okay? So by the time we're at 100 degrees, we're 65% output. By the time we're at 150 degrees, those fans are on full speed. Again, it can be configured any which way you want on this table. It does not have to be based off of coolant temperature as well. So what I mean by that is if I come over to the custom, or you may have the generic menu. You're going to go into your generic / custom menu, whichever one you have, and you're going to choose the PWMX parameters menu. Okay. So now you're going to see here that you have the ability to come in here and say in the X-axis data source, I'm doing coolant for both. All right. So, but you have all these other different conditions you can choose as well. You can choose 0 to 5 volt inputs that you have. You have, if you're in a different gear, you want to choose air temperature, manifold pressure, the race timer. Again, you can do it any which way you want. You can also do a 2D table. So if I was to come over here and do 2D, then I could say, okay, now I want that PWM output to work in a 2D mode. Okay, so now if I go back and I hit apply and I come down to this PWM07 curve, you're now going to see here that it's now set up based off of boost, okay, on the vertical axis and coolant on the horizontal axis, okay? So again, this is just an example, but I could say if I'm below 5 pounds of boost, and I'm at 50 degrees of temperature, I'm going to have this whole column be equal to 30, something like that. Actually, let me make this all 30%. Again, this is just for examples here, okay? And then by the time I got to 120 degrees, okay, I want to be at 100%. Come over here, interpolate horizontally, this icon here, okay? So now you can see here that now I'm filling in, and now I've got the ability to, below this boost, ramp it up. Now let's just say if I'm above 5 pounds of boost up to 10 pounds, I want to go 100%. So I'm just going to interpolate that. I'm sorry. Yes, I want to go to this vertically. And then I can now either copy this line, or I can just say, you know what, I just want to have it 100% over here as well. And then I can interpolate again horizontally. And now, again, as we make more boost, as we make more temperature, the fan will go on more. Okay. This can be figured any which way. You can choose any axis that you want to be able to work with. Okay. It doesn't matter. But just an example of how you could use this curve. And again, it does not have to be for a fan, a water pump. This could be for a fuel pump. Anything you want to control PWM wise can be used on these tables. All right. So if I go back to PWM08, I'm still just set up here as a 1D or 2D curve to be able to utilize the electric fan just based on the 1D curve application. Okay. So now everything is set up, everything is configured. If I was to come back over here to the 1D axis on the PWM07, I would come back down here, hit up 7, and then there's my data right there. Okay. Again, you can run this any which way you want. All right. So now what we're going to do is we're going to fire this up for real, and we're actually going to watch the outputs increase based on the engine getting warmer and running. Okay. So engine's running. We're maintaining about 160 degrees right now of coolant temperature. And we have named the outputs electric water pump for PWM7 and electric fan output for PWM08. If I go back to the graphic logging section here, I'm actually already logging it, and you can see here that right now we're both at 100% on those outputs for that I had named electric water pump and electric fan output. Now, if I wanted to make some adjustments here and actually watch this stuff change, come back over to tuning and dyno views, come back down here to the 07 curve, and instead of making we'll do the fan, for example, instead of making it 100% 150, I'll go to 200 degrees and then interpolate that out. All right, and then if I go back to my logger, you can now see that the electric fan has dropped and we're now maintaining around 82% duty cycle, and it'll start ramping up as the coolant temperature warms up there. Okay, so this is it in real time. You've now configured the tables. Remember, the custom port editor or generic port editor has to be configured to activate the tables, but then once the tables are actually enabled and running, you can then play with them to your heart's content. If you have the newer software, you can do them as a 1D or a 2D table. But that's it. That's exactly how it works. And don't forget, if you have the newer firmware version, you could add the custom names, and the custom name will be shown inside here of your application, however you actually named those outputs, those PWMs. So if you have any questions, please give us a shout at BigStuffTPM.com. You can also reach us on Instagram, send us a message on Facebook Messenger. You can also send us an email at support@BigStuffTPM.com. Hopefully you guys like this video. It's very helpful to you, and give us a shout if you have any questions, and we'll talk to you soon. Thank you.